Professor Joshi DM from Parsons Technical Campus, Ahmedabad. Today, we conduct lecture on fractional horsepower motors. Last lecture we listen and understand the concept of DC motor, but in case of DC motor there are some limitations like continuous power supply in domestic or household equipments are generally operated on an AC supply. Means in practice only AC supply is available. Because of that we use AC supply for the common purpose, and we don't use the DC supply for the common purpose. So for household or industrial purpose we cannot use DC motor because of the separate power supply. So we use only AC supply. So the motor which operates on AC supply is called as induction motor, and we study here about the fractional horsepower motors. That means induction motors, but single phase induction motors. Now we start the lecture. What is meant by induction motor? Induction motor is the motor which operates on the AC supply. It's called as induction motor. Then what is the construction of induction motor? The construction of the induction motor is same as like of DC motor. Here also one stator and one rotor is present. That means without stator and rotor no construction of motor is possible. Here also one stator is present and one rotor is also present, but the construction of the rotor is somewhat different from the DC up to the DC motor, because the rotor of the fractional horsepower motor consists of cylindrical drum, which is like which shape is like a squirrel cage. Because of that, the rotor of the single phase induction motor is called as squirrel cage rotor. Okay, because its shape is like a squirrel cage, and the stator of the fractional horsepower motor is like that. Here, rotor of the fractional horsepower motor is like that. This is the cross section of the rotor. This portion is called cylindrical. And here this hole is provided for the damping rods. Damping rods or dampers or damping bars. These bars are made from copper, and the whole structure is like of the DC of the induction motor rotor is like that. Like that. Both the ends of cylindrical rotor are enclosed by the end plates, and this kind of rods or damping bars or dampers are present in the rotor cage. So this structure is like a cage. Because of that, it is called as squirrel cage rotor, and these dampers are used to perform the role like conductor. And the stator of the fractional horsepower motor the stator of the fraction horsepower motor is same as that of DC motor, and the stator consists of the field winding. Okay. Now, the rotor working as a secondary winding and the stator working as a primary winding. After that, what is the working of the fraction horsepower motor? When electrical AC supply is given to the stator of the stator winding of the motor, then if the AC supply is moving towards the stator winding, it produces tremendous amount of magnetic fluxes, and these fluxes travel between the gap of stator and the rotor, and this fluxes is called as RMF, that is rotating magnetic field. This magnetic field linked with the stator. Let's draw the circuit diagram so we can understand easily. It is the stator, and this is the rotor. Okay. When we use electrical supply to the stator, it generates magnetic flux. The nature of the magnetic flux is alternating because the given supply is alternating. This magnetic fluxes produces rotating magnetic field, that is RMF, produces rotating magnetic field because the nature of the fluxes is alternating. This rotating magnetic field RMF is continuously rotating around the stator. Because of this magnetic fluxes, the rotor conductors generates EMF due to the transformer action, and this rotor also induces magnetic fluxes. So this point there are two types of magnetic fluxes produced. First magnetic flux is the main magnetic flux, which is produced by the stator, and secondary magnetic flux, which is produced by the rotor. So here two type of magnetic fluxes are produced, and the nature of both the magnetic fluxes is the nature of the stator magnetic fluxes is alternating, but the nature of the rotor magnetic fluxes is also alternating. So here two types of fluxes interact with each other, and the resultant of the two magnetic fluxes produces the torque. Okay. So by this principle we understand that to rotate any kind of fraction horsepower motor or any kind of induction motor, it requires two types of fluxes, and the resultant of that fluxes produces the torque, which is responsible to rotate the motor. But there are two conditions to start the single phase induction motor self-starting. First condition is that the single phase induction motor requires two types of winding. Okay, but we observe here only the stator consists of the winding. The rotor doesn't consist of any kind of winding. It consists of only dampers or the bars. So in case of single phase induction motor, there is only one winding, and single winding does not produces two types of fluxes. So single phase induction motor is never self-starting. To start the single phase induction motor, there are only two conditions. If these two conditions are satisfied, then and then only the single phase induction motor will get started. What are these conditions? First condition is that to produce induction motor, it requires two type of magnetic fluxes, and these two type of magnetic fluxes are 90 degree, having the place 90 degree with each other. Means first flux is vertical, then it must be second flux, then the second flux should be in 90 degree with each other. Then and then only the resultant of these two fluxes produces torque. Okay. First condition is that. So in single phase induction motor there is only one winding. So this motor is not self-starting. Then second condition, the two fluxes should be 90 degree phase shifted with each other. That means after the 90 degree, 90 electrical radian, if the first winding is, first electrical current is flowing, after the 90 electrical radian, second current should be passed. That means first current is here, then second current should be start from here. Okay, that means 90 degree phase shifting is compulsory to run the induction motor. So to run the induction motor, we have to satisfy these two conditions, and to satisfy these two conditions, we have to make some modification in the induction motor winding to produce the 90 degree shifting, to produce the two types of fluxes. So what are that modifications? The classification of the induction motor is depend upon that modification. What type of modification we done? The classification is depend upon that. Means if we retain the winding by a resistance, the type of induction motor is a resistance split phase motor. If we inserted a capacitor in the induction motor, the motor is capacitor start induction motor. If we place permanently capacitor in the winding, then the motor is capacitor start capacitor run. And if we shade it to the stator poles, then the type is shaded pole induction motor. That means there are four types of induction motors. There are four. The classification of induction motor is divided into four types. First is resistance split phase induction motor. Second is capacitor start induction motor. Third is capacitor start capacitor run induction motor. And the last one is shaded pole induction motor. Let us see first type, resistance split phase induction motor. First type, resistance split phase induction motor. First of all, we draw the circuit diagram of resistance split phase induction motor, so we understand easily. First of all, we draw here stator. After that, the stator. We draw here winding. We draw here second winding. Then centrifugal switch, and across this combination we have to connect the single phase AC supply. So to start this type of to start the induction motor, what we did here, we divide the main winding in two sections. First section we call main winding, and second section we call auxiliary winding. Or starting winding, and this is the switch or the centrifugal switch, the switch which operates on the pressure centrifugal switch. This is the construction of resistance split phase induction motor. Here we retain the main winding by using the resistance. Because of that, called here split phase induction motor. Now, what is the working of this type of induction motor? Let us discuss. If the current I, that is total current, start from this point, this current is divided into two parts. First current is called I1 and second current is called I2. The main winding is highly inductive in nature. Because of that, the main current I1 is lag behind the supply voltage V1. Okay, and the second winding, that is auxiliary winding, it is highly resistive in nature. Because of that, the current I2 is in phase with the supply voltage. That means there are two types of current flowing, and because of that, two types of magnetic fluxes are produced. Okay, but in first case, the current I1 is flowing through highly inductive winding. Because of that, the I1 current is lag behind the supply voltage by 90 degree. Okay, after that the current I2 is flowing from highly resistive winding. Because of that, the supply voltage and the I2, the phase difference between is in phase. That means both are in phase. What happens here? The first winding produces flux in 90 degree and the second winding produces in phase. That means here 90 degree phase shifting is happens and 90 degree phase angle is also here occurred. Because of that, the resultant of both the fluxes produces the torque. It is called zero initial start torque. This torque is responsible to rotate the induction motor self-starting. After the induction motor reaches its maximum or synchronous speed up to the 70 to 80 degree, the centrifugal switch get automatically open and the auxiliary winding is disconnected from the supply and the induction motor runs only on the single winding. Okay, this is the resistance split phase induction motor. After that, we see second type of induction motor, that is capacitor start induction motor. In the capacitor start induction motor, the circuit diagram is also same, but here a single modification is done. Instead of a resistance, here we place a capacitor, and after that a centrifugal switch. This is the capacitor and this is also auxiliary winding and it is main winding. Now what happened here is the supply voltage V1 is parallel with the main winding, and the current also divided into two parts. First I1, second I2. The current I1 passes through the main winding. We know that the main winding is highly inductive in nature. Because of that, the current I1 lags to the V1. That means this type of winding is highly inductive winding. So here lagging happens, and after that the current I2 passes through the winding, but here capacitor is connected. We know the properties of capacitor. It responsible to leading the electrical current. Because of that, current get highly in leading. So here a large leading angle is created between the first current and the second current. So here also this is the I1 current, this is the I2 current, and because of that Phi1 produces, because of that Phi2 produces, and the resultant of these two fluxes produces torque, and this torque is responsible for the responsible for the rotation of the single phase induction motor. This type of induction motor having very good power factor. So preferably this type of induction motors are used in the industries or the power sectors. After that, third one is capacitor start capacitor run motor. The construction of the capacitor start run and capacitor start capacitor run motor and capacitor start induction motor is near about same. Here only one modification is done. Instead of this centrifugal switch, we keep the capacitor permanently in the circuit. Okay, what happens? What we did here, we remove the centrifugal switch and we kept the capacitor remain in the circuit. So what happens here? There are two types of winding. First is main winding, second is auxiliary winding, and the main current I1 passes from I2 and main current I1 is divided into two currents. First is I1 current, second is I2 current. I1 current passes from the main winding. The main winding is highly inductive in nature. Because of that, I1 current is lag behind the supply voltage V1. Then I2 current travel from the starting winding, but in the circuit capacitor is present. Because of that, I2 current leads to the secondary winding. That means the lagging current is produced in secondary winding and leading current produced in the primary winding. Because of that, large amount of angle is created between the two fluxes, flux phi 1 and phi 2, and the resultant of the two fluxes phi 1 and phi 2 produces the torque. So this type of motor, what is the main advantage of this type of motor is that here compulsory or permanent capacitor is present. Because of that, the power factor is very improved as compared to the capacitor start induction motor and very much improved as compared to the resistance split phase induction motor. And the last one is the shaded pole induction motor. What happens in case of shaded pole induction motor? In the shaded pole induction motor, we have to split the pole of the induction. The pole of the stator winding is like that, and we did here bending of the splitted pole by the copper shading. So all the fluxes concentrated on shaded band, and the resultant torque is produced. In case of the shaded pole induction motor. So you understand this topic very well, and